Light by Marianne Lerian. What you already know, we live in a world filled with energy. Light is a form of energy. Objects such as the moon reflect light. Light will also refract when it passes through water. Energy comes in many different forms other than light. Potential energy has the ability to change to another form in order to work or cause a change. When we burn fuels, we release their potential energy. Kinetic energy is the energy of motion. Whenever we begin to walk or run, potential energy changes to kinetic energy. Thermal energy is the total energy of all the particles in matter. The thermal energy in a heated room is what warms. Sources of light. Daylight is the result of Earth receiving light from the sun as it turns on its axis. As Earth rotates, part of it enters into darkness, and other part comes into daylight. Most of Earth experiences both day and night every 24 hours. The sun is not our only source of natural light. The nighttime stars shine brightly. The planet you see in the night sky, such as Venus, shine also. But the light the planets give off is not their own. Like the moon, Venus reflects the sun's light. Lightning is a form of electricity. It creates huge amounts of light. Fireflies and some kind of fish also make natural light. The sun will always be our most important source of light, but artificial light gives us light when it's dark outside. For the past century, we have been using electric power lights in our homes and schools and on city streets. Before electricity was used for light, people used campfires, oil and gas lamps, and wax candles. These types of light sources are still used today. However, electric power lights are our main source of artificial light. Traveling light. Light travels very fast, much faster than sound. That's why you see a flash of lightning before you hear the sound of thunder, even though both happen at exactly the same time. Light travels in straight lines. A flashlight beam shows this. If you shine a flashlight on a wall, you can mark where its beam of light hits. The distance from the mark back to the flashlight is always a straight line. Traveling light rays react differently when they reach different types of materials. Transparent materials allow all light rays to travel through them. Translucent material allows some light to shine through them. Frosted glass, stained glass windows, and dark sunglasses are translucent. Opaque materials such as doors, walls, and our bodies block out all light rays. Opaque materials absorb and reflect light. Does light pass through? Colored water lets light rays pass through easily. Milky water allows only some rays to pass through, while ink blocks them completely. Light and shadow. Light rays travel from the sun to Earth. When they reach an opaque object on Earth's surface, they are unable to pass through it. This causes a dark area, or shadow, to form on the surface on the other side of the object. The shadow takes the same form as the object. Shadows change length throughout the day. They are shortest at noon. Shadows get longer as the sun appears to move lower in the sky. The most amazing shadow of all is seen during a solar eclipse. A solar eclipse is when the moon passes between the sun and Earth. This causes the moon's shadow to fall on Earth's surface. Shadows have been used for centuries to tell time. A sundial is a kind of clock. It tells time using a shadow created by the sun. Obviously, sundials can measure the time at night. Bouncing light. Long ago, people thought that their eyes sent out beams of light to the object they saw around them. But people have shown that idea to be false. We now know that light rays bounce off objects and enter our eyes. When light bounces off an object, it is called reflected light. Light rays reflect differently off smooth and rough surfaces. Suppose you shine a flashlight on the surface of a smooth mirror. The mirror reflects the light in only one direction. How we see. We can see objects that are not light sources because light rays bounce off the objects and enter our eyes. Now, think about what would happen if you shine a flashlight on a leaf. The leaf's rough, uneven surface could scatter the light in all directions. These scattered, reflected light rays allow you to see the leaf from all sides. When light rays bounce off an object, most of the light is reflected, but not all. Some light is absorbed. All objects, no matter how transparent, translucent, or opaque they are, absorb some light. Reflections. Reflections are formed by shiny materials, such as glass mirrors and smooth water surface. Most metals reflect the light that falls on them. Glass is not a metal. However, it is usually very flat and smooth, like most metals. Since glass does not reflect light rays well, how are glass mirrors able to reflect our image? Mirrors are made by putting metal sheeting up behind a piece of glass. The glass protects the metal. It also makes a smooth surface. It is the metal that reflects our image back to us, not the glass. Curved surface. Have you ever looked at your reflection in a spoon? The way the front of a spoon is curved can make your image appear larger and upside down. The curve of the back of the spoon can make your image appear smaller. Mirrors can be used in many different ways. We can use them to see our appearance. Mirrors can also help us stay safe. Bicycle riders, car riders, and other vehicle operators use mirrors to help them see while they are driving or riding. Finally, mirrors can be used to send flashes of light over long distance. This is a form of communication. Bending light. You already know that light moves through air at an amazing speed. When light travels through other materials, such as water or glass, its speed decreases. The slowing down of light rays causes them to change direction. Refraction is the name given to the slowing down of light rays. Because of the way the light gets refracted through water, underwater objects appear larger than they actually are. Refraction also causes our skin to absorb more of the sun's heat energy while we're in the water. That makes it very important to wear sunscreen while swimming. Lenses. A lens is a specially shaped piece of glass or plastic. It refracts light in a precise way. A concave lens spreads light way apart, which makes objects appear smaller than normal. A convex lens focuses or brings to a point the light rays of an object that is far away. We can find many examples of refraction in our daily lives. A spoon placed at an angle in a glass of water appears bent. A pencil seen through a water field jar may appear to be broken. Lenses are used in eyeglasses, microscopes, telescopes, and magnifying glasses. By using refraction, these lenses help people see better. Using refraction. We use refraction created by lenses every day for many different things. Lenses can be used to make objects that are far away look larger. They can also correct poor eyesight and focus light rays into a very strong beam. People are born with two very important lenses. Each eye contains a lens. The lens is located just behind the pupil of each eye. The pupil is the black dot located in the very middle of each eye. This light-heavy light uses a specially shaped lens to create a very strong beam of light. As we move our eyes from near to distant objects, special muscles attached to the lenses pull the lenses into different shapes. By changing shapes, the lenses allow us to focus clearly on objects both near and far. As people get older, their eyes lenses can change shape. This can cause their vision to blur. We can wear contact lenses on or eyeglasses to correct our eyesight. A camera works a lot like our eyes do. A convex lens uses light coming into the camera to help create a clear, focused picture or image. Splitting light. Have you ever wondered what white light is? Sunlight and light from an electric light bulb seem to be colorless. We call there two kinds of light: white light. White light is a mixture of many different colors of white. Those colors become separated when white light passes through a prism. A prism is a triangle gluer, transparent block. Light passing through a prism forms a band of colors called a spectrum. An object's color tells us which color it reflects. Grass is green because that is the only color it reflects. The glass absorbs the other color in the spectrum. If an object appears red, it is because it is absorbing every color except red. The red rays are reflected off the object. Most of the light that you see each day is white light. However, not all light is white light. Red, green, and blue light only give off toast water. Colors. Light can be any color found in the color spectrum. Rainbow colors. You can see a rainbow because raindrops act like tiny prisms. White light enters a droplet of water. The water bends or refracts each color in the light differently, but then the light passes out through the droplet, but it no longer appears as white light. Instead, the light is split into its colors. Rainbows occur most often after rainfall or when there is fog. That is when a lot of water hangs in the air. That water creates rainbows. How rainbows form. Light from the sun passes through raindrops in the air and gets refracted. The refraction causes rainbows to form. Curved bands of colored light are produced when a rainbow forms. The sharpest rainbows are called primary rainbows. They show the full spectrum of colors. The colors in a primary rainbow are violet, indigo, blue, green, yellow, orange, and red. People are able to see these colors. Light in our lives. The sun gives us a light. It provides our planet with energy. Light makes plants grow. Light makes it possible for people and animals to live on Earth. Stars and the moon's reflected light brighten the night sky. Natural light is much more than give us day and night. It allows us to see different colors, reflections, and shadows. Light rays reflect and refract. These properties are used in many light-based inventions. Our lives are made happier, healthier, and safer with lighthouse light, mirrors, eyeglasses, and other inventions. It's very easy for us to take light for granted. After all, the sun appears to rise every day. We flip a switch and our homes, offices, and streets are lit by electric-powered lights. So it's important to remember that light is one of our most important resources. Without light, we would not be here. the universe would be left in the dark.